this video, we briefly introduced our work named a 4-port shared aperture and band full-duplex antenna array based on a novel common mode and differential mode combination method. The further details can be found in IEEE transactions on antennas and propagation. In band full-duplex, which allows for simultaneous transmission and reception of signals in the same frequency, is a promising solution to spectrum congestion. Most existing IBFD antennas have a shared aperture with 2 ports, as shown in figures 1A and B. However, they offer only a single polarization, for either TX or RX, as maximizing spectral efficiency. A more effective IBFD system should include 4 channels, each with 2 polarizations for both the TX and RX, as shown in figures 1C and D. The coupling between different ports involves distinct mechanisms that must be simultaneously addressed. In this work, a 4-port shared aperture IBFD antenna array with consistent radiation patterns is achieved using a novel common mode and differential mode combination method. Compared with separated aperture IBFD antenna, it achieves better performance by improving the aperture utilization efficiency from 50% to 100%. In addition, as shown in Figure 2, this work leverages 2 orthogonal modes to enable high isolation between antenna ports, eliminating the need for complex decoupling structures or networks. A sub-array system is first proposed, which comprises 2 dual polarized patch antennas and 2 180-degree hybrid couplers. The high isolation between the sum and differential ports of the couplers between the CM and DM modes, as well as the orthogonality between VP and HP, results in a high isolation between the 4 modes. However, radiation patterns of the 4 modes significantly differ from each other. To address this issue with the radiation patterns, the CM and DM combination method is proposed. This system uses 2 subarrays that have been appropriately combined. The main concept is to ensure that any of the 4 ports excites the 2 subarrays simultaneously, one in the CM mode and the other in the DM mode. To validate the proposed method, a 2x2 antenna array with feeding networks is simulated, fabricated, and measured. The measured bandwidth of all the ports can cover the 3.3 to 3.8 GHz. The measured isolation between any ports is more than 38 dB. The radiation patterns are broadside and quite similar, when exciting different, with a gain of more than 8 dB. The results indicate the system is a compelling candidate for a wide range of 5G sub-6 GHz applications, and is particularly beneficial for base stations due to its coverage capabilities. Thanks for listening.